The goal is to make it helpful for you. I will also call up on some of you just to make sure everybody is following and with me. Okay, if you guys can hear me and understand, give me a thumbs up or a yay or nay on the chat, please. Awesome. Awesome. All right, so let's get started here. And I'm hoping you all can see my screen. If not, just put it in the chat and we'll try to figure this out. I'm also offering, and this is something new for me, as you know, I usually provide kind of free sessions, but there is a lot of requests for private tutoring. I can only, since I work full time, I can only do 1 or 2 private tutoring sessions in a month. However, I'm offering this GMAT Math Doubts package for $25 a month. You can ask me unlimited questions via email. I would respond by email. And if there is a really good question, I would respond with a personalized video. So you can actually watch the video and follow. If you are interested in it, you don't have to buy it. This is just for your information. If you're interested, send me an email and we can talk about it. So that was kind of my sell. And let's get started. So we'll get started with a very simple thing. Is a story. This is when I was very little, right? And we were learning about, I was probably in like 9th grade when we were learning about velocity. And a friend of mine who had just, and we had just covered the speed, time, distance thing, and we talked about fuel burning. Obviously, after fuel burning, our teacher kind of gave a lecture about how it is, you know, impacting climate and pollution and things like that. So we were doing distance, you know, velocity and displacement and things like that. And one of my friends got very excited. He was like, well, sir, if, you know, if I'm going positive, and I hope you can see my hand here, if I'm going positive, I burn fuel, but if I go negative, I burn fuel in negative. So I should be able to make fuel, right? And the teacher kind of looked at him, and I still remember what he said. And he said, distance is never negative. That has stayed with me. And that is exactly what absolute value is about, distance. It is distance between any 2 points. It is never negative. If you are going, for example, from 2 to X in this direction, you will burn the same amount of fuel if you go from 2 to X in that direction. So direction doesn't matter. Distance is always positive. In other words, the distance between 2 and X here and X and 2 here, doesn't matter where X is, left side of 2 or right side of 2, it is going to be always the same. And how do you measure the distance between 2 points? Here you write X minus 2. And here you would write, because 2 is greater than X, you would write 2 minus X, because X is greater. Here X is greater than 2 because it's on the right hand side of the number line. Here X is smaller than 2, so 2 minus X would be positive, because remember, distance is never negative. Now, same thing around minus 2. How would you calculate distance of point X with minus 2? Here you would say X minus minus 2, which becomes X plus 2. And here you would do minus 2 minus X, right? But this is still minus 2 plus X, and distance is never negative. So actual distance is 2 plus X, not minus 2 plus X, okay? So the distance is always positive, always, distance is never negative. And whether you're counting this way or that way, we take out negative and we only consider kind of non-negative quantities. So mathematicians then started thinking like, okay, you know what, this is good, but I can't just keep having like, oh, if x is greater than -2, then I write this way. But if x is less than -2, then I write this way. Similarly here, how do I express distance in a way that I don't have to write 15 different conditions when I'm trying to express something? And this is when they came up with this sign saying, which is called modulus, which is basically says anything inside of modulus. So x minus 2 could be positive or could be negative. But when you put modulus around it, this is always non-negative, right? So this will be non-negative. So I'll take a quick pulse here. Any questions so far? Raise hands. If you're all following me, then awesome. Can you all hear me? I see some new people joined. Okay, awesome. So let's take an exercise. And I am given in the number line a point A, and my x is here. What is the distance? If I have to express the distance of x and A, what is the distance between x and A in terms of a modulus sign? And I'm going to pick one of you to answer this question. Salman, how about you go? And if you don't have the mic, you can put it on the chat for everyone to see. Correct. So if you look at here, right, A is definitely greater than x. So you can write it as x minus A. And this is the most common way of expressing it. You can also write it as A minus x. Since it is a modulus sign, it's the same thing, which even if any of these is negative, the modulus will take care of it and make it positive. Similarly, distance of x from point minus A. Nikita, how about you go and you can speak?
Yeah, modulus x plus A.
Modulus x plus A. Very nice.
X minus A.
Correct. So that is absolutely right. Looks like we are all following the basics. That is awesome. So here is a question for you guys. Oops, what happened? All right, so now if we have to look at distance of point x from -9, as we talked about, this is of the form x and minus A, it will be x plus 9. Distance of point 0.5 would be x minus 0.5, or you can also say 0.5 minus x. It is the exact same thing. It just depends on how you express it. I have this 7.3 plus x modulus of, right? What does it represent the distance of x from? Pallavi, how about you go?
Hello?
You might have to increase your volume a little bit.
Yeah, hello, can you hear me? Hello?
We can, but it's very, like, I don't know guys about you guys, but I can hear Pallavi, but it's very faint, very far off.
Okay.
You can also type it up, Pallavi, if that helps.
Yeah, I am typing out. Actually, it represents the distance of x from minus of 7.3.
Correct. So this is the distance of x from minus 7.3, expressed this way. And as you get more used to modulus, just remember these things, because these will help you solve a lot of problems, and we'll see how distance formula helps solve some of the important problems. Okay, so now I want everybody to respond on the chat if possible. True or false? What have we learned so far? modulus of x is greater than 0. All right, I have 3. I'm looking for a couple more responses before I give the answer. Yep, so the answer is actually it's only partially true. And this could be a trick that GMAT asks you. You have to be very mindful of this. If you remember, I kept saying distance can't be negative, distance can't be negative. I never said distance has to be positive, right? Modulus doesn't have to be positive. As Salman rightly said, it can be 0. And this is important to remember. Unless the question gives you, and we'll see a OG question which specifically gives x is not 0 or the variable is not 0, then you know you don't have to take 0. Otherwise, it is important to consider 0, right? And what does it mean that modulus of x is 0? Basically, x and 0 are at the same point. So there is no distance between them. They are at the same point. All right, everybody good so far? Any questions? If there is a question, please raise your hands. All right, awesome. So let's continue. Let me just quickly look at the participant list to understand how many more people have joined so far. Okay. Anga, welcome. Thanks for joining. We had about 15 participants, so I'm hoping more will join the session. All right, so now we talk about the mathematical definition, right? We already talked about this. This basically mod of x, first of all, represents, just like mod of x minus a represents the distance between x and a, mod of x represents distance between x and 0, whatever that distance is. It is always greater than or equal to 0. So you have to think about 0 when you are solving the problem. Don't forget it. And we have certain properties that first 2 I will solve for you. The third one is a little more difficult and I want you to answer me and I'll pick someone, okay? So minus x, see, negative inside a modulus sign doesn't make a difference. So I can easily write mod of minus x as mod of x. Mod of minus 2 as mod of 2. They are the exact same thing. When you open them up, depending on what the real value of x is, positive or negative, it will be different, but the quantity is always positive, and a negative sign out inside of modulus doesn't matter. If x is greater than 5 and I want to open up the modulus now, right? How would I write this? Would it be x minus 5 or 5 minus x? How about Salman, you go. Salman, you there? Okay, maybe Salman is not there. Anga, how about you go?
I don't actually. This topic is fairly new to me. The instruction is if x is greater than 5, and then what is the question?
Let's open up the modulus. Let's express this without the modulus. And thanks for communicating and participating here. I appreciate it.
Okay, thank you. So can you give me an example, please?
Yeah, so let's say x is 6, okay, right? So if x is 6, x is greater than 5. So 6
Right.
minus 5 is 1, which is positive. So what that means is
Yes.
when x is greater than 5, the quantity inside the modulus sign is already positive. So I
Yes.
can, when I open up the modulus, I can just write it as is. I don't have to worry about a negative sign, right? Modulus can never be negative. So this is fairly
Right.
positive. X is greater than 5. It will always be positive. So I'm expressing it the right way.
Right.
Good.
So if x is greater than 9, so let's say 10, and then if we want to open the next modulus, so x minus 10, it would be minus 1. So that you say that the distance cannot be negative, so I should write it as x minus 9. Is that so?
Perfect. Perfect.
Oh, right. Okay.
Perfect. So, so this is the right way about thinking about distance and how to open up the modulus. And I'll give you some more tricks in the advanced topics. It will make it much more easier to kind of solve these kind of problems and open up the modulus. Half of the battle around modulus is figuring out how to open it up. And you have already kind of made good progress towards that.
Thank you.
So then let's follow up with that with a question. And I'll pick Pallavi to answer this question. Modulus of x minus 9 is equal to modulus of 9 minus x. True or false?
When here it is x is greater than 9, means
It's
it is
not
the
given.
condition.
It's not given.
Okay. Okay. X minus 9, modulus of x minus 9, 9 minus x. I don't think it is true, means it's false, I think.
Okay, so let's think about, oh, sorry, this is really bad number line. Let me try to make a straighter number line. I think this is straight enough. Let's think about what does modulus represent. When you're trying to solve this problem, always think about like what does modulus represent. So we talked about it represents the distance between x and 9, right? So the distance between x and 9, wherever x is, whether it's on this side of 9 or that side of 9, which is x minus 9 versus 9 minus x, is always going to be the same, right?
Okay.
So
Yeah.
that's why these two quantities are always going to be the same. In the end, when you open up the modulus, whatever is the positive quantity, 9 minus x or x minus 9, it will be that quantity. And let's take an example. Let's take x equal to 10, right? So this becomes 10 minus 9, which is 1. And modulus of 1 will be 1 because
1.
it has to be non-negative. This would be 9 minus 10, which is minus 1.
Minus 1, yeah.
And minus 1 modulus is also 1.
1.
All right. So again, the inside sign doesn't matter. The expression doesn't matter because the distance is always the same. So different way of representing it, but the more you think in terms of distance and things like that, the easier some of the solutions will become for you. And it will not happen in one day. So just absorb. If you have any questions, please definitely ask. But go back and think about it. This session is also getting recorded, so I will send you a recording of the session. That way you can follow. I'll upload it to my YouTube as well. Okay. All right. So another question. So this one is if x is equal to x is less than 0. So I'm given that x is negative quantity. Is x divided by mod of x equal to 1. So now we have raised the complexity a tiny little bit. And Nikita, how about you go this time in thinking about this problem?
Yeah, this should be false because modulus x will always be positive, and because x is less than 0, so x will be negative. So negative over positive will be negative.
Correct.
So it should be -1.
Correct. Very good. Very good. And what would mod x be? Let me follow up with this question. How would I, if I want to open up this bracket, what would mod x be? Would it be, let me just give x or minus x? Who wants to take that question?
It
I'm
should
not
be
sure.
minus x.
Should be minus x, right? So even though this looks as negatives, x is given to be negative, modulus cannot be negative, so it can definitely not be x.
Yeah.
So it has to be minus x because minus counters the negative x, whatever negative part of x is, and makes it positive. So modulus of x equal to minus x. And this trips up a lot of people, makes for some 650 to 700 level GMAT questions. However, if you kind of think it this way, that it's the distance, it can never be negative, the answer very easily follows. When you open mod x up, it has to be either x or minus x. The question is, can it be x? If x is given to be negative, then the answer is no, it can't be x, it can't be negative. The opposite of x would be definitely positive, so it will be minus x. All right. If x is less than 0, is mod x equal to x squared divided by x? Is this true or false? Anga, you want to take an attempt at it, and it is fine if you want to talk it out and you don't know the answer. We will see if we can work it out together.
Sure, thank you for the opportunity. I think it's true. Let's assume that x, the value of x is -1. So mod -1 should be 1 equals -1 squared. It should be 1 plus. I think over -1. I think it should be negative and therefore false.
So yeah, it definitely looked like it is true.
Yeah.
But as you
Yes.
worked it out, it became
Right.
apparent that it was false. And again, something that can be asked in GMAT, especially when x is given to be negative, because kind of negative sign is hidden,
Yes.
and it can confuse you. So the way you worked out is perfect. And you could also see that, you know, I could just cancel out x and x because it's given less than 0. I don't have to worry about 0. And I get mod x equal to x. Very simply, x is given to be negative. How can positive sign, right, mod of x equal to a negative quantity x? That cannot happen, so it's false.
Yes.
All right. So some of the, we're kind of changing up a notch here and talking about what kind of operations you can do and take inside the modulus signs and what kind of operations you can't, right? And it is important to know when you are trying to solve equations in modulus. If you don't know, you can make a mistake. So let's look at it. I'm going to drive most of this, but if you have questions, please raise your hands or talk. It's absolutely fine. So I'm given 2x equal to 6. 2 is a positive quantity. Since it's a positive quantity, whether it is inside the modulus in the multiplication or outside the modulus, it doesn't matter. So I can basically write it as 2 mod of x equal to 6. Because it's a positive quantity, it didn't matter. And I can write it, and then I can divide it on both sides by 2, and I can say mod x equal to 3. This is perfectly fine. Multiplying a positive quantity across or dividing a positive quantity across is absolutely fine. Similarly, I have mod x divided by 2 equal to 3. Since this is positive, I can write it as like this: half x mod x equal to 3. I can multiply both sides by 2, and I get mod x equal to 6. This is absolutely fine as well. This is where things start becoming a little tricky. minus x. So now this negative sign, as we initially talked about, right? Negative sign inside the modulus doesn't mean anything. So you can basically do two things. You can say, yes, x mod of minus x equal to 3, since negative sign doesn't matter. You can also immediately write mod x equal to 3. But let's kind of think about what would have happened if you had switched. So, and did exact same thing that you did here, which is if you had taken the minus sign outside of the modulus equal to 3 and multiplied both sides by -1, you would get distance, which is always non-negative, equal to a negative quantity, which is not possible, right? And this is why when you are manipulating the modulus sign, it is better never to take a negative quantity out of inside the modulus sign. You can completely take it off. So this one is correct because minus x modulus and x modulus are the same thing. Modulus can eat up the negative sign. However, taking a negative sign outside the modulus or pulling it in the modulus is not right. Don't do it. This will lead you to a bad answer as it did here. So the lesson here is don't multiply or divide negative quantities without opening the modulus first. If you're able to somehow figure out how to open the modulus, for example, if it were given to me that x is negative or positive, then I have opened up the modulus, which means I don't have this modulus sign anymore, and I have something like this. At that point, you can just treat it as an equation. Okay, I will take a pause here because this was kind of involved, at least this part of the question. Are there any questions or follow-ups that I should help you guys with? Going once.
So far so good, I guess.
All right. Let's move on. I think we have a practice question. So what I would like you guys to do is apply the concepts you have, and we'll do it together also, but apply the concept we have learned and try to solve this question and put your answers in the chat. And meanwhile, we have another participant, Ishant. Welcome to the group. You've missed some of the basics. Hopefully you are still able to follow the topic. It's very open. So if you have a mic, please come in. We are talking, we are discussing. I'm picking one of you to answer some of the questions, trying to make as interactive as possible. At this point, we are trying to solve this official guide to GMAT question. Please try to solve it and put your answers in the chat. Okay, we have heard from almost everybody. Okay, I think we have heard from everybody. except Anga, but that's fine. If you want to take a little bit more time, I can kind of start explaining the question because we have a lot of more material to cover, especially advanced topics. And I think we are already around 40 minutes. So we are given a few things, and let me start by asking a question, and we'll call on Ishan so that we get some participation out of him. True or false? Ishan, how can you look at the screen and let us know if this is true or false?
Well, it's false. It depends actually if x is positive, or I mean if x is anything greater or less than 0, then this is true. If x is 0, then it's false.
Yep, perfect. So this is something I was just testing while it occurred to me that this could be a possibility in a question like this. It's not relevant. So let's move on. So we are given that x is equal to minus of w in the modulus. So what can we immediately say? We know that this guy, right, the modulus sign is always positive. It is modulus, or at least we can say that it is not negative. So not positive, but it's definitely not negative. So it could be 0 or positive, which makes x either negative or 0. Okay. X is not positive. That is for sure. Now, the question asks us which of the following must be true. X equal to minus w. We don't know what the w is. We cannot tell based on this equation. W could be 0, then x equal to w is fine. W could actually be negative, in which case x and w are the same. And w could also be positive. So this is definitely not something we can tell. Similarly, x equal to w, we can't say. We know that x is going to be the opposite sign of this. So x is either negative or 0, but we don't know anything about w. W could be positive or negative. I'll take an example so that it's clear, right? So let's take w as minus 1. So x is minus of the modulus of minus 1, which is minus 1. So x also is minus 1. So x and w are equal. However, if w were positive, 2, x is minus of 2, right? So x is the negative of w. So in some cases, it could be equal to w. In some cases, it can't. This is definitely not relevant because there is no relation given between x square and w. X square and w equals w square. So we are given this, right? How are we going to get x square? By squaring both sides. So we can square both sides since it's an equality, but remember, we can't open the modulus sign yet. So I am going to square it. When I square it, of course, the minus is minus 1. When I square the minus 1, it will go away. So this will become, and I can write it like this because again, w square is already positive. And since w square is already positive, I can take out the modulus sign, open it up, and write it as w square. So x square equals w square makes perfect sense, and hence D is the answer. Let's look at E because E could be confusing to some people. Let me wipe this out. X cube and w cube. So again, what we have here is if we cube the equation, I have minus w cube, right? So I still have minus 1 multiplied by, because minus cubed is minus 1 multiplied by w cube. So this is a positive quantity, of course, and so the cube of this would be positive quantity. Sorry, it's a non-negative quantity, so the cube of it would be non-negative. Again, it would be 0. But there is this negative sign, and I don't know anything about w. So I can't say that x cube is equal to w cube, just like I can't say if x equal to w or x equal to minus w. Hence, E is not an answer. take a pause here and see if everybody is good with this question, is following it, if there is any thoughts or concerns or things that are not clear. If you are not okay with the question, please feel free to ask. Meanwhile, why don't you guys take a couple minutes to solve this question and we'll try to solve it together. And yeah, please put your answers in the chat. Okay, 30 more seconds. Please put your answers in and then we'll start solving it. If you guys can still hear me, just doing a voice check, please raise your hand, give a thumbs up. Oh, so this is a data sufficiency question. So you're saying both are not sufficient. So the standard choices of data sufficiency, let me write it down, and I'm sorry, I kind of assumed you guys are all familiar with it. Statement 1 is sufficient to answer the question. The question being, is mod x equal to 1? Choice B is statement 2 is sufficient to answer the question alone. So statement 1 alone, statement 2 alone. Choice C is statement 1 plus statement 2 are sufficient to answer the question, but not alone. Choice D, each statement alone is sufficient to answer the question. And choice E is neither statement. Even when you combine them, they are not sufficient to answer the question. So I'm looking for answer in A, B, C, D, E. If you want to try again, Nikita. We have one answer in D. Anga, how are you doing? Ishan, how about you? We have one E. Anga has E. And Nikita, I think you said both are false, so I'm assuming you meant E as well. Just wanted to confirm. And you can speak if you want. A, okay. All right. So now, gotcha. All right, so now let's try to solve it together. This is, remember in the start of the presentation, I said there are some times when it will be clearly given that it's not 0. One of the variables is not 0. And the reason GMAT gives us there is a y in the denominator. So they don't want to confuse you, because when the 0 goes in denominator, it kind of creates out of scope possibilities, and they don't want you to get confused around those. So they are very clear. This is kind of GMAT gold standard, that they will specify very clearly if a 0 in the denominator is possible or not, right? And it's always not possible. So if you're trying to solve a problem and you are seeing that a 0 comes in the denominator, just think again, because GMAT just specifies it always that it's not 0. And similarly, think 0 in the 0 to the power of 0 will not be something that you will see in GMAT. If you are solving a problem and you're getting such a possibility, then either you are solving something wrong, or you have to reread the question to make sure that 0 is not possible. 0 to the power of 0 is not possible. So it's clearly given that y is not 0, not given whether y is positive or negative. So we have to consider both possibility. And the question is a yes or no question. It's saying, is modulus of x equal to 1? What does that mean, right? So let's think about it. So question is modulus of x equal to 1? And we have to, from these equations, either come to a yes, it is equal to 1, or no, it is not equal to 1. We cannot come with an answer of maybe. If we come with an answer of maybe, then it's not sufficient. For a sufficient, we have to have a true yes or a true no. Either is fine, because we are answering the question confidently that yes, it is a yes, or no, it's a no. All right. So is mod x equal to 1? Right. So remember, x is the distance. Mod x is the distance of x from 0. So x could be here and x could be here. And this is the mod x distance. And the question says, is it equal to 1? What that comes down to is which point is 1 unit away from 0. 1 and minus 1, right? So x equal to 1 or x equal to minus 1. So there is two ways to interpret this question. Is mod x equal to 1, or is x equal to minus 1 or 1? Either one is fine. If it is minus 1, then we know it's mod x equal to 1. Then it answers yes to the question. If it is x equal to 1, then mod x is also equal to 1. Then it also answers the question as yes, and we are good. So statement 1 says x equals y divided by mod y. Now remember, we are not given whether y is positive or negative. So you don't know how to open up this modulus. If y is negative, then you open up the modulus with a minus y, because minus y will be positive. If y is positive, then you can open up the modulus as y, which is possible, right? However, the question actually asks about modulus of 1. So I can just say the positive quantity modulus of 1 would be the positive quantity modulus of y divided by mod y. So modulus of x will be equal to mod of y divided by mod of y. Right? This is two mods don't change the fact that the initial mod was always positive. So this will be equal to mod of y divided by mod of y. Cancel, because they are both positive. The answer is 1. So we already get mod of x is 1. And the answer is yes to the asked question. We don't have any doubt about it. So the answer is yes to the asked question. And hence A is definitely sufficient. Let's do it in one different way, because this taking mod on both sides is slightly advanced concept and it may not click during the GMAT. So let's take a different way. And let's take two conditions, right? Because we know that y is non-zero, but we don't know if it is negative or positive. So we take y as greater than 0, the easy case first, which means my mod y, I can open it up as y, positive and positive. So my mod y divided by y becomes 1. which means my x, which is mod y, oh sorry, oops. My y divided by mod y equals 1, which is also my x. So x equals 1, and since it's positive, mod x will also equal 1. So my answer to the question is yes. But remember, I have another possibility that y is negative. So let's solve for that possibility also. I can't answer A yet. Y is less than 0. In this case, what would be my mod of y? Can you all put it in the chat? If I open up the modulus for y, remember y is negative. So if I put mod y as y, then I'm saying positive quantity equals a negative quantity, which can't happen, right? So mod y has to be minus y. This is same as one of the questions we did earlier. So mod y is minus y. So if I want to open up the modulus when y is less than 0, I will have to write it as minus y. So the equation x becomes y divided by minus y, which becomes minus 1. So x is minus 1, but again, modulus of x is equal to 1. So question is x mod of x equal to 1? The answer is yes. So in both cases, I am getting a resounding yes to the asked question. Hence, statement A is sufficient. I'll take a pause here and see if everybody is following. Anga, I haven't heard from you for a little bit, so I just want to make sure you are following, and this is kind of making like helping you understand what's going on. And you can speak. Are you saying something? I can't hear you.
Yeah, I'm actually trying to taking the concept, I would say.
Okay.
Yeah, sure.
Right.
Thank
And
you
is
for
it
the
helping? You can always go back and review because this session is getting recorded and I'll post
Yes.
on my YouTube channel. Okay.
Thank you.
All right. Any other questions, thoughts on statement A, and then we'll go to statement B. We have established that statement A is sufficient at this point. Okay, so I'm moving on. Statement A is telling me mod of x equals minus x. What does that mean? This is a positive quantity, and it's telling me that this also has to be a positive quantity if mod of x is never negative, or it can be 0, but that's fine. Yes, x is negative or 0, right? X is not given to be non-zero, so we have to consider 0. So keep reminding yourself that 0 is a possibility, because it's very easy to forget. And as you said, when I was expressing myself, even I forgot, and I have to catch myself sometimes. So keep reminding yourself that 0 is a possibility here also. So either way, right? If x were 0, for example, then mod of 0 will be 0. So is x equal to 1? That's the question it asks me. And the answer is no. Mod of x is not equal to 1. And it still satisfies statement B. Let's say x cannot be positive. We know that much, right? But x could be minus 1. So minus of minus 1 equal to minus 1. So we have 1 equals 1. So in this case, we get a yes answer, that yes, mod of x equal to 1, which is agreeable to the asked question. Let's take another thing. We know that x is either negative or 0. So we can take minus of minus 2. Let's take x equal to minus 2. and we get 2 equals 2, which is also possible. How does this answer the question that is asked? Is x equal to 1? It says no again, right? So as you can see, in some cases, we are getting no to the asked question. The asked question is mod of x equal to 1. And in some other cases, it is answering yes to the asked question. So we don't have a unique yes or no. Sometimes it is yes, sometimes it is no. So it is kind of a maybe. Hence, B is definitely insufficient. We cannot get the answer from B. I'll take a pause here and see if there are any questions. Is everybody okay? In the next topic, we are going to go a little more advanced. So I just want to make sure the concept is clear and you guys are all good. Give me a thumbs up or put it in the chat. And if there is a question, please come on the mic or put it in the chat as well.
I would just like to understand statement 2 once.
Okay. What part of it, Nikita?
So 0 is equal to 0 is not sufficient. Okay, that's okay. I got it. Yes.
So yes, so look at it this way, right?
That
0
answers the
equal to
question.
0 satisfies this condition. Absolutely, right? However, the question asked is mod x equal to 1? And of course, mod x equal to 0 here, right? So look at it, think about it this way. So mod x equal to 0, that's why it answers the question in a no. Does
Yes,
that
got
help?
it. Thank you. Yeah.
Okay. Any other questions? Thank you for asking that question. All right, so let's move on. Get your pencils ready because we are getting into some bigger concepts. I thought, okay. I need to create a page. I thought I had kept a page for myself, but I didn't. So let's go back to the page here. Did we have somebody new join? Hi, thanks for joining. We are kind of halfway into the class. You can still follow. If there are any questions, please feel free to ask, and just know that it is being recorded, and I'm hoping it is being recorded. So if you don't follow something, that is absolutely fine. I will send you the recording so that you can view the recording later on. We are very interactive here. So if there is a question, raise your hand or open up your speaker or put and ask, or you can put a question on the chat. I'm following both. All right. So now we are going to talk about a little bit advanced topics. We are kind of over the basics. Doesn't mean that basics were simple. Absolute value is a kind of a complex topic. It takes just going through it again and again to get to a point where you get more comfortable, and it is fine if you're not feeling comfortable. At this point, it will take some more practice. Now, we are going to talk about this concept called opening up the absolute value sign. This is one of those skills that once you get comfortable with it, you are going to be able to solve some of the very complex problems very, very easily. You may not get comfortable with it today. However, follow along, ask any questions you have, and go back, just try to do it on your own. And I have a couple of questions to showcase the power of this. I know Manali was going to join, she didn't. This one of the questions came up in my WhatsApp group about this, where this technique applies, and it helps you solve that question. And we have that question later on to solve for ourselves. So I will start by taking very simple examples. If you are not following, please feel free to raise up your hands. Let's talk about it. It's very important for you to understand. You don't have to be an expert at the end of this class, but if you understand the basic concept, you will be able to apply it repeatedly. And as you apply it repeatedly, you will get better and better at it. All right. So let's say I give you this and I ask you to open it up, right? We've all seen what this means. This means distance between X and 4. We all drew the number line and we said, if 4 is here, X could be on this side of 4 or X could be on this side of 4. And, you know, this is same as 4 minus X and things like that. We also did that if X is greater than 4, then I can open it up and write it as X minus 4. If X is less than 4, then I can open it up and write it as 4 minus X, right? We did all of that. However, if you can see, there is a complexity here where you have to kind of create these equations. X is greater than 4, X is less than 4. And if there are more than one terms in a question, it starts becoming extremely complex. So the method I'm outlining here is a systematic approach to solve these kind of problems. And again, try to follow. Please ask questions if you are not following, because that will give you the most benefit. And let's see how we will solve these kind of questions step by step. Okay. So first, let me just give you an expression here. So I'm going to give you two expressions, X minus 4 plus X minus 1. Very simply. And let's say we have to calculate this. And again, as you can see, we had X is greater than 4, X is less than 4 for this. And we had X is greater than 1 and X is less than 1 for this. So we have 4 different ranges where we have to find, and things change, and it starts getting more complicated if you add more terms. So here is how I recommend you think about it and you solve it. The first step is, forget about this guy for now. Let's take just X minus 4. Think about when this expression becomes 0. It becomes 0 when X equals to 4. Why is that important? Because in the number line, that is where I'm going to anchor myself, wherever X is 4. So let's take X is equal to 4 here. And take a value greater than 4. That is step number 2. Take a value greater than 4 and see what happens to this quantity. 5 minus 4 is 1, right? So it's positive. So what that means is when I'm taking X greater than 4, I'm getting X minus 4 is positive. So anything greater than 4, which is the right side of number line, I am getting X minus 4 is positive. So I can write it as is. Anything left of number line, doesn't matter where the point is, it will be negative, right? Because let's take number 3, which is less than 4. So 3 minus 4 is minus 1. Modulus cannot be negative. So I would have to take minus of X minus 4 for when X is less than 4. So anything here, I am saying minus of X minus 4. And this is very crucial, right? So 3 steps. First, find the anchor point, which is when you put X and 4, X minus 4 equal to 0 and you denote it. Then you take 1 point more than that and see how the equation looks. So we saw that X minus 4 is positive. So which means for any point greater than X minus 4, sorry, for any point greater than 4, you can write the term as is. And on the opposite side, just put a minus sign. 3 steps. I'll take a pause here and see if there are any questions so far. Feel free to put it in the chat or ask. Okay, I'm assuming no questions. We are going to apply exact same 3 steps for this term over here. So let's take X minus 1. And the first step is, when is this 0? When x equal to 1. So my anchor point is 1. So this is 4. So 1 has to be somewhere here. Let's assume this is 1. And we have x minus 1 here. So let me take as 2 a point greater than 1. So let's take x equal to 2. 2 minus 1 is positive, which means for all the points greater than 1, I will get x minus 2 as the positive quantity. So I can open up modulus as x minus 2. Next, take a point which is less than 1. So let's take x equal to 0. I get minus 1. So minus 1 cannot be a distance. It has to be negative of minus 1. So anything less than 1 would be minus of x minus 2. So now I have opened up the equation completely. I had two terms. I had defined two boundaries of it. And I have said for anything greater than 1, and I have three ranges, right? This range, which is less than 1, another range, which is between 1 and 4, and another range, which is greater than 4. And I have created terms that apply for each range without writing the ranges down, as this is x minus 4, anywhere greater than 4, anywhere less than 4. So in this range, it will be minus x minus 4. And in this range also, it would be minus x minus 4. It is anywhere less than 1, it is minus x minus 2. Anywhere greater than 1, it will be x minus 2. So I have written it down as x minus 2 in this range. It will be the same in that range. I'll take a pause here and see if there is any questions, confusion, something you want me to explain a little more, then I will go ahead and explain. And
Sir, is it x minus 2 or x minus 1? I couldn't understand, sir.
You are absolutely right. That was my bad. It is
got
x minus
confused
1.
actually.
Yes, I am sorry. It is all x minus 1. Thanks for correcting that. We were just taking x equal to 2. Yeah, I'm sorry. I hope that doesn't create a lot of confusion. Thanks for catching that, Pallavi. Any other thoughts or questions? Everybody good? Thumbs up? Okay. All right. So now you have three ranges, as I said, right? Range number 1, which is less than 1. Range number 2, which is less than between 1 and 4. And range number 3 between 4 and above. This is how you solve problems like this. You automatically have ranges because you have calculated those anchor points. You have given the expressions within these ranges, and now there is a plus sign in it. So you can just add these up at this point and get the different values in the ranges. So minus x minus 4 would be minus x plus 4. And minus of x minus 1 would be minus of x plus 1. So you get minus 2x plus 5 in this range. So that would be the value. You have minus x plus 4 again from here. Here the things change. So you have x minus 1. So you get a very interesting thing that in this range, value of x really doesn't matter. The sum will be 3, no matter where you are. Whichever point you are, will always get 3. And finally, here you will get x minus 4 plus x minus 1, and you will get 2x minus 5. So you get 3 different values for 3 different ranges, and depending on additional kind of statements that are given in the question, then you will be able to solve this. Any questions on the approach? Any thoughts on the approach? Do you find it easy or difficult? Please let me know. It definitely will take some practice, and we are going to practice it more in some of the other questions I have.
Sir, I have a question. For example, if there is another means set, for example, x minus 4, x minus 1, and another is there x minus 2. Therefore, the number of sets will increase, means this divisions actually.
Yes, the number of ranges or divisions.
Ranges, yeah.
Yeah,
Yeah.
will
Then
definitely.
we have to consider all the ranges then, means.
Yes, we have to consider all the ranges, and we follow kind of the same steps. And we will see that is definitely there in one of the practice questions. And Pallavi, you are there in the WhatsApp group, so you saw the question that was posted yesterday, right? So it had 3, and that is one of the questions we will solve today.
Okay.
All right, any other questions? Okay, and if some of you are not in the WhatsApp group but would like to be part of the WhatsApp group, it's a free group. Please just email me and I'll send you the link. The link is also there in my Facebook group, so either is fine. You should be able to find it. So here is a practice question. We're going to practice this approach, and then we are going to try another concept to solve these kind of questions. So the question is, find x where x satisfies these conditions. You are not going to get this kind of question in GMAT. This is more of a explaining the concept kind of question. However, similar questions can be asked in GMAT where they can say x is in which range, or which of the following x satisfies this condition, and things like that. So it is definitely in scope and applicable. I have kind of created this a little bit open scoped question, and that's why I'm saying it will not come in GMAT. And the reason I did it is to demonstrate the approach to all of you. Okay, so we will again do step by step. First step, for all of these terms, we are going to find the anchor points. And I've already done kind of the hard work here so that we can save some time, but let's look at it, right? X plus 4 is 0 when x equal to minus 4. So I have this anchor point right here. 5 minus x is 0 when x equal to 5. So I have this anchor point right here. And 9 plus x is 0 when x equals minus 9. So I have this anchor point right here. And I have just marked 0 because it helps me orient myself. And I recommend you do the same. It is not part of the ranges. It just kind of helps orient you, like what are the ranges and where does the 0 lie, right? So we have this range over here, this range over here, this range over here, and then this range. Those are the 4 ranges we get as a result of these 3 terms. And it starts looking a little bit daunting here, but still let's apply our approach to each of these and we will come to an answer very, very quickly. Okay. So let's look at x plus 4. So our anchor point for this is minus 4. So we don't care about the other anchor points at this point. We only need to know how would I open up this bracket, or sorry, this modulus sign when I am around x minus 4. This is the one that matters for this. So if I have a number which is greater than minus 4, which is, let's say, minus 3 or 0. Let's take 0. It's easier, right? 0 plus 4 would be 4, which is positive. So what that means is greater than minus 4, I get the expression positive, so I can write it as is. I don't have to change it. So now anything greater than 4, I can just write x plus 4. And remember, my range was this one. So in this range, it is x plus 4. And anything greater than 5, it is also x plus 4. So I'm just repeating it in each range. The value is not changing. And what will it be under minus 4? You can take an example, minus 5, and you will see minus 5 plus 4 is negative, right? Minus 1. So you have to put a minus sign. As you start practicing, you would be very simply just doing this. If it is x plus 4 on this side, then on the opposite side, it would be just the negative of that. So for these ranges, I am going to write it as minus of x plus 4. And anything less than minus 9 also, I'm going to write it as minus of x plus 4. Sorry. And this is it. This is, I have basically opened up the x plus 4 modulus into these 4 ranges I had with these terms, and I can pick. Let's look at 5 minus x. What is the important anchor point here? This one. Anything greater than 5. Let's take 6. 5 minus x is 5 minus 6, which is minus 1. So it's negative. So I have to reverse it to make it positive, right? So that means for greater than 5, 5 minus x would be written as negative of 5 minus x. And you can quickly check it again, right? Let's take x equal to 10. 5 minus 10 is minus 5. And I have a negative sign here, which makes it plus 5, right? And I'm opening up the modulus, so it has to be always positive. Just keep that in mind. And anything here, it will be negative of that, which means it will be positive 5 minus x. So in this range, it will be 5 minus x. In this range, it will be 5 minus x. In this range also, it will be 5 minus x. Now remember, there is a negative sign here. As you can see, I'm keeping it separate. That will be my step number 4 after I have actually done these ranges. Then I will apply the sign, otherwise I will get confused. So don't apply it yet. I'm keeping it separate and we will come back to this sign. 9 plus x. So if I take 9 plus x, our anchor point is minus 9. If I take a point greater than 9, let's just take 0, then 9 plus x is positive, right? 9. So that means anything greater than minus 9, I can write it as is. Anything less than, I have to reverse it or put a negative sign. So in this, anything greater than 9, it is same. So I'm going to write 9 plus x. I'm going to write 9 plus x in this range, and I can write 9 plus x in this range. And for this quantity, I'm going to flip it, and I'm going to just put a minus sign in front of it to make things easier. So now I have 4 ranges: less than minus 9, between minus 9 and minus 4, between 4 and 5. Remember, 0 is not part of the range. 0 is just to orient myself, and 5 greater than 5. These are my ranges, 4 ranges. And I have already broken down the terms. What I have not done yet is taken care of this minus sign, because it kind of changes things. So now let's take care of this minus sign. I can cancel out this minus sign and apply it here systematically, so that now all my terms are in positive, or like the negative are taken care of. Right now, I can just add these 2 terms up because I've taken care of the minus sign here. And I have to basically see if these 2, when they are added, equals this in any of the ranges. That will be the range where x will lie. Okay, I'll take a small pause here and see if there are any questions. Otherwise, we will start solving it. Is everybody following the approach? Thumbs up, thumbs down. Frowny face. Are you guys still there? Okay. All right. Anga, how are you doing?
Yes, I'm still here.
Okay.
Yep.
Is it little more advanced than what you are used to?
I guess, yeah.
Yeah.
So I've not, I'm not around math for the past 4 years. So it's like refreshing, I guess, refreshing the memory.
Okay, perfect.
Yep.
All right. So, and again, it's a new approach. It is slightly advanced concept. So if it takes you a while to get used to it, that's absolutely fine. It's a very systematic approach. So if you get stuck in GMAT, this approach will help. We will also solve it with the distance problem, and it is not applicable 100%, but it also helps solve some of these problems. All right, so now the next step is very simple. At this point, and when I say simple, it's like from all the complicated things we did so far, the next step is probably the easiest one of all, right? Which is, these are my ranges, right? And I have to take these terms, and my question basically said this plus this equal to this, and I have to see if that is what happens to X and what kind of values do I get for X, and is it even possible? So I will solve this one on this side and leave it as an exercise for you all to solve it at home. You can take a screenshot if you want, so that you can use it to solve at home. So let's take this, right? So minus X plus 4 becomes minus X minus 4 plus minus 5 plus X. So X cancels, and this becomes minus 9, and that equals minus 9 minus X. So again, minus 9 and minus 9 will cancel. This will give us X equal to 0. So our range itself was X is less than minus 9. And when we solve this equation, we are getting X equal to 0. Is that possible? 0 is, this is why I was like orienting myself. I can see X equal to 0 is here. My range is here. So this is not possible, right? So when I solve this equation, I get a very weird answer, which is X equal to 0, but X cannot be 0. I'm saying X has to be less than minus 9. So this is not a possible. So in this range, this equation is not possible. And what you will find is, in any of the ranges, this equation is not possible for all the ranges when you calculate. And that is why there is no possible value of X where this equation actually holds, is the answer to this question. Again, it was a demonstrative question. You would likely not get it in GMAT. I'll just take a pause here. If there are any questions to the approach or what I am doing here, please let me know. If everything is good, we are going to flip the question and look at it from a distance perspective, and it will help you kind of think through how to solve these kind of problems with distance concept. Okay, looks like there are no questions. So let me try to move this guy. Okay. All right. So in terms of distance, right? Okay, so I can't see the question. Again, the distance, I'm going to rewrite the question a little bit, because finding the difference is tougher in distance problems when they are, but finding the addition is simple. So first thing I'm going to do when I'm looking from a distance perspective is I'm going to rewrite it as X plus 4 equals 9 plus X plus 5 minus X. The quantity on negative side, I took it here. Okay. Now what I'm saying is the distance between X and 4 equals the distance between 9 and X, or minus 9 and X, and 5 and X. All right. So again, we start with the anchor points. That is always the starting point. So we have minus 9 as our starting point. We have minus 4 as our anchor point. And we have 5 as one of the anchor points. And as I said, let's just keep 0 to anchor us where the 0 is. So now the question asks the distance between X and 4. So let's just say X is somewhere here. Then if this is X, then the distance between X and 4 is this one, right? distance between x and -9, this is the distance between x and -9 as we did initially, then this is the distance between x and -9, and we are adding with it the distance between x and 5, which is this distance. You can see that the x and 5 distance is already more than x and -4 distance, and you are adding another distance to it. There is no way they can be equal. So x cannot lie here. This is not a possible range for x. All right. So let's take out x from there. Let's say x is somewhere here. Then the distance between x and -4 will be this distance, very small. And again, x and -9 will be this, plus x and 5 will be this. Again, you can see that there is no way this quantity can be equal to this quantity plus this quantity. This quantity is already more than this quantity, right? So x cannot lie in this range either. So we get rid of x again, cannot be there. -4 and 5. So let's assume x is somewhere here. So the distance between x and 4 is this guy. The distance between x and 5 is this guy. But distance between x and -9 is this guy. As you can again see, the distance between x cannot be equal to the distance between this plus this, because obviously, again, this is a lot more. So x cannot lie here. And finally, you can take another x somewhere here, and you will find that the distance between these two will be greater than this one. So it can never be equal. So x cannot lie here. So basically, you've looked at all the ranges just with the distance instead of kind of solving it with the step-by-step approach. And you have come to a conclusion that x is just not possible. Right? I'm going to pause here and see if there are any questions. Okay, no questions. Everybody good? I'm hoping everybody is good. If there are questions, please ask me for sure. So if we can solve this kind of problems with the distance, why did we go through the big approach on the left-hand side? That may be a question that is coming in your mind. And the answer is the distance concept is not always applicable. There is a chance it will be applicable, but it is not always applicable. If you follow my YouTube channels, I have more questions using using distance method to solve those questions. Please go through them. Distance method is not applicable to all situations, and hence we had to go through with that longer method. However, that is also very systematic, and it can help you solve some of the 700+ level GMAT questions. All right, so let's go on to the next question. I think it is one of those 700 level GMAT questions. It is, and we are going to solve it by ourselves, again applying the method systematically. I will do it for the first two ranges and leave it as an exercise so that you can apply it on your own. And can everybody see my screen and look at the question? Please give me a yay nay in the chat or a thumbs up on the window, please. All right, awesome. So this is a question that came up in our WhatsApp group. I'm actually surprised Manali didn't join. She wanted to understand how to solve these problems. And as you can see, it is a direct application of the approach that we just did, and it is a lot more complicated because there are 4 terms here, which is fine. The approach still applies, and it applies very well. The approach is definitely time consuming. The more you practice, the better you will get at it. So that is fine. You are going to spend some time on it. There is a simpler way to solve this question, which if you are in GMAT, you need to know both. If you are able to apply that simple method to solve the question, awesome. If you're not able to solve by the simple method, then you have that approach in your toolkit and you can use that approach with it and do it. Okay, I will start with the simple method because see, I know this problem comes out as like, oh my God, however, it's not. And how do you do it? By taking values. So the first step, even when you're trying to solve this question, right? The first step is to find the anchors. Any kind of GMAT question or modulus question where you have these kind of expressions, it is always good to start with these anchor points. They will orient you towards, what are the different ranges, make you see the problem more clearly. So that will be the first step. Even though we don't apply our approach in the solution I'm giving you right now, we still need to do that particular piece. And it's very simple, right? So we put x minus 3 equal to 0. So x equal to 3 is this. And to orient myself, I put 0 here. So 0 is somewhere here. X minus 4, so I have this. X minus 6, so I have this. There is a little bit of 5 here. And x minus 7. So 7 is my another anchor point. So these are my anchor points. Good. Now, the question asks, what is the value of this? When question is asking you this is again a data sufficiency question, and it's asking if these are sufficient. The answer is sufficient when you get a unique value. The value cannot be 4x plus 5, because then it depends on the value of x. And if it depends on the value of x, it is not sufficient. So it cannot depend on value of x. That's the main thing, right? And it has to be a unique value, then it's sufficient. If it depends on the value x, then it's not sufficient. The easiest way to solve this question is take up values. So when x is an odd integer, so we will take something in this range. So let's say 1, of course 3. So we'll take 3, something in this range 5, and anything more than 7. So those are kind of the points. The problem with the values approach is you can never be sure. You've taken certain values and you may be getting a certain answer, but there could be values somewhere else where you will get a different answer. However, you may not have time in the GMAT, and taking value is a solid approach, especially in questions like these, which are very complicated. They would likely not give you a trap where there are many such values possible. And if you take 1, 3, 5, 7, let's take 1 for example. So 1 minus 3 is minus 2 in the mod, so that becomes 2. Minus 2 times x minus 4, so x is 1, 1 minus 3 is minus 3. So that gives us plus 6. Plus 2 multiplied by x minus 6, x is 1, so minus 5. So minus 5, right? I am sorry, I've been doing it very fast and I've been doing it wrong. Let's do it again. So minus 2 into x minus 4. X minus 4 is minus 3. Since it is inside the modulus, let me just write inside the modulus. As you can see, even I can make these kind of mistakes, which is fine when you are in a hurry. Just catch yourself and try again. X minus 6 is going to be minus 5. I'm going to write minus 5 as is. Minus x minus 7 is going to be minus 6. I'm going to write it as is. In the next step, let me simplify it. Of course, modulus cannot be negative, so I can write it as 2. This will become 3. 3 multiplied by minus 2 would be minus 6. Plus 10 plus 6. And
It should be minus 6, right?
you are right. That's the mistake I was making. Because the modulus, when you open up the modulus, this becomes 6, and there is a negative sign here, so it's minus 6. So as you can see, this becomes 0, right? 12, 10 plus 2 is 12, minus 6 is 12. So this becomes 0. Let's take another example. 3 and 5 will be 0 as well. You can calculate it very simple. Let's take 7, for example. So 7 minus 3 is 4. Minus 2, 7 minus 4 is minus 3. 3. plus 2, 7 minus 6 is 1, minus 7 minus 7 is 0, so it doesn't matter. So I get 4 minus 6 plus 2 equals 0. So I'm getting consistently 0. For 3 and 5, I will get consistently 0 as well. If you want just to be comfortable, you can take a value greater than 7, which is right there outside of the ranges, and you will again get 0. So for x is an odd integer, you will consistently get 0 as a value. You can assume that A will be the right answer, and you can say A is sufficient. At least that much you know. Any thoughts, questions on this approach? Fairly straightforward approach. Yeah. Now x is greater than 6. Can somebody give me a greater than 6 value that I can apply to this question? Seven, but we already solved for 7 and we know the answer is 0. Any other values? Anga, how about you give me a value? 9. All right, so let's try 9. So again, we are trying to solve this. So 9 minus 3 is 6. Let me just write it as is, minus 2. 9 minus 5 is 9 minus 4 is 5. Plus 2, 9 minus 6 is 3. Minus 9 minus 7 is 2. So I get 6 minus 10 plus 6 minus 2, I get a 0. So for 9 also I'm getting a 0, but we know that because we already did it for x is an odd integer. So we are just kind of reinforcing the same thought. Any other values? But let's not take only odd values, right? We should take some even values also. So let's take 12 now. All right, so let's take 12. So 12 minus 3 is going to be 9, minus 2, 12 minus 4 will be 8, plus 2x, 12 minus 6 would be 6. Sorry. Minus 12 minus 7 would be 5. So I get 9 minus 16 plus 12 minus 5. So this is 21 minus 21. So this is again 0. So I'm getting 0 again. And what you will see is if you keep taking integers, you will get 0 value. But is x given to be an integer? Exactly. So, and this is the kind of trick in this question. If you keep taking, whether you take even or odd, especially above 6, you are always going to get 0. But x is not given to be an integer. And as soon as you take some non-integer value, it falls apart. It doesn't come to 0. And that is why x greater than 6 is not sufficient to answer the question. And let's take a value just to kind of prove the point here. 6.5 minus, let's take 6.5. Excuse me, 6.5 minus 3 is 3.5 minus 2. 6.5 minus 4 is 2.5 plus 6.5 minus 6 is 0.5 minus 6.5 minus 7 is 0.5 again. Right, so you have 3.5 minus 5 plus 1 minus 0.5, and as you can see, this will not be 0, right? It's 4.5 minus 5.5. This is equal to around minus 1. So this was the trick in this question. And again, if you assume everything is an integer, where they had to specify, they specified it very clearly that it is an integer. In this case, it will not be an integer. And here is the important part. This may not be immediately visible to you. So always think about like, does it have to be an integer? When we solve it using our step-by-step method, you will definitely see that, you know, there are expression between these ranges, and you will solve for them and you will come to the answers. However, if you forget that within those ranges, let's say this range between 6 and 7, there are actually values of x that we can apply, you will still falter. And so just keep reminding yourself that check for 0, check for is x or any other unknown quantity given to be an integer or not. All right. Any questions on this approach? Let me just do a quick time check. We are actually over time, but that is absolutely fine. We'll take 5-6 more minutes to actually apply the approach systematically. And I will solve for one of the ranges and then leave it as an exercise. How does that sound? Everybody good with that?
That sounds good.
All right. So let me go to the next page. I did some of the pre-work for us so that we spend less time on it. If you guys had to go and I'm taking up additional time, I apologize. And hopefully you're finding value in this one. So let's start with the first expression, x minus 3. Anchor point is 3. And I know that any value greater than 3 will yield me x minus 3 as positive. 4 minus 3 is 1, 6 minus 3 is 2. So it is as I can open up the bracket as is in any of these ranges. So let me write it for that. So it will be this. And for the opposite ranges, it will be negative. So let me write that. Okay. Similarly, I will open up this one. As usual, the negative sign before this, I'm going to take care at the last so that I don't get confused systematically, right? So again, x minus 4, 4 is my anchor point. So anything above 4, I can write as is, and 2 is not making a whole lot of difference. So I can write as is. And anything here, I will just flip it. John, I see that you just joined. We are almost at the end of the presentation. However, it will be recorded and I'll send you the recording on my YouTube channel. Hopefully you can follow. However, if you have any questions, please feel free to ask. X minus 6, very similar. For anything greater than x equal to 6, I can write it as is. So I'm just going to do that. As you can see, once you start practicing it, it becomes faster. It's not the same thing when I was trying to explain everything to you, right? Under 6, it will be just the opposite of that. So then it becomes mechanical. You don't have to think too much at a certain point. Right, then we have x minus 7. X7 is here. Anything above, I can write it as is. And anything below, I'm going to write it with a minus sign. This is a pretty tedious problem because of so many terms involved. It's a Manhattan GMAT problem and you know, a really tough problem. So a 750 plus level GMAT problem. However, it's a good problem to kind of understand this concept and approach, right? So we have broken down these ranges. Remember, 0 was just there for anchoring ourselves. It's not part of the range. So the actual ranges were these. And now what we haven't done yet is taken care of these signs. So they may trip us up. So let's take these signs and apply a minus sign everywhere. So it will kind of change these to this and apply this minus sign here also. So systematically, I have integrated the minus sign as well, the negative sign. And now I have the expressions in different ranges, and all I have to do is calculate it in different ranges. You can do the math on your own. What you will find is anything below 3, you will get this as 0. And why are you getting this 0? You can see that 2x and minus 2x will cancel. You can see minus x and x will cancel. And actually all the other terms will add up to 0. In this range, you will get 2x minus 6. Again, you can do the calculation. I have the calculation written down here just to speed things up. Here you will get minus 2x plus 10, 2x minus 14. And again, anything more than 7, as we saw previously, it is 0. And you can see again that I forgot to write a 2 here, sorry. So minus 2x and 2x will cancel, minus x and x will cancel, and rest of the terms will cancel as well. So now let's solve the question, right? We took out this quantity, arranged it in the ranges, and we have kind of simplified the whole expression in different ranges. Let's take statement 1, x is an odd integer. So x is an odd integer. There is an odd integer here, which is 1. There is no odd integer between 3 and 4. So I don't really care about this range for statement A. Between 4 and 6, there is an odd integer 5. Between 6 and 7, there is no odd integer. And with 7 and above, there is some sub-odd integers, including 7, right? So we can see that for 1 and 3 in this range, the answer is 0. So that is a specific answer. So we are good. This range, we don't even care because there is no odd integer between 3 and 4. We do care about 5. And let's put 5 in this expression to get what do we get, because in this range, it does depend on x. So depending on the value of x, the expression can change. However, for 5, you see that it will become minus 10 plus 10. Will become 0 again. So it is consistently, we are getting for odd integers the value of 0 for the overall expression. No odd integers between 6 and 7. So forget about that. And from 7 on, for any integer, it is 0. So it doesn't matter. So what you get is when x is odd, it's given to be odd and also positive, you know that even this range is not needed, right? You're given this one. The value is always 0. And when the value is always 0, the answer to the asked question is yes. So A is definitely sufficient. I'll take a pause here, see if there is any question that I can solve quickly before I move on to statement number B. Everybody following? Good. Thumbs up. Sorry, John, looks like you had a question. You can speak up or put it on the chat if I saw. I'm sorry, I missed your message. I'm sorry, I missed your chat before. Do we still have John on? We do. Okay, all right, so let's move on to the next one, right? So now the question says x is greater than 6. How do we solve that x is greater than 6? We forget about these ranges. These ranges are not in contention anymore because x is given to be more than 6. Now we know that when x is greater than 7, it is 0. So this is consistent. We get this as consistent result. However, between 6 and 7, it depends on x. And this is where you can get tripped up. However, you have to keep in mind that x is not given to be an integer. So you have to take some values between 6 and 7. And you would realize that it is non-zero answer. When it is a non-zero answer, you are getting two different answers for the asked question. 0 when it's greater than 7 or 7, and between 6 and 7 for the non-integers, it is a non-zero. So sometimes you get a 0, sometimes you get a non-zero. You don't get a unique value. Hence, the answer is no to the asked question. Oh, sorry, not no to the asked question. The answer is insufficient because you get two different answers. And so the answer to this question is A. And John, if that's what you were referring to, that the answer is A, then that is correct. That brings us to the end of the presentation. As I said, it is recorded, so I will send you the recording. Hopefully I get a recording out of Zoom. If not, I am planning to create some videos anyways with the same strategies, and I will post and I'll send it to you. We had a lot of people sign up, but only few showed up, but I'm hoping that this helped and you were able to get value out of this particular session. I totally understand, and don't beat yourself up if you were not able to follow or understand every question. It takes time. It is one of the more complicated topics in GMAT. However, the strategies outlined here are very, very applicable to pretty much any question that you come across. So just revise this video, the concepts that we have learned here, the approaches we have talked about, and hopefully that helps you solve some of these complicated questions more easily. And finally, I will send you 3 things. 1, a link to the recorded copy or recorded video of this session. Number 2, a link to my my YouTube channel. And you're welcome to please, if you like what I did here, please subscribe to my channel, like the video. It helps me with YouTube. I'm doing this all for free. 3, another pitch, small sales pitch about this GMAT Math Doubts package, which gives you unlimited access to me via email to answer any questions. And if there are some really good questions, I do take it upon myself to create a video, personalized video, and send it to you. And again, thank you very much for your time. If there are any questions for this particular session, please let me know. All the best with your GMAT preparation. Thank you, everyone.
Thank you.